So this is about pancreatic cancer and what a terrible disease it is. And just to kind of highlight that, it's not a common disease, or not especially common. There are about 10,000 cases in this country, in the UK, a year. And there are about 10,000 deaths a year as well. Now, the fact that those two numbers are basically the same, this is telling you something about whether it's a very survivable disease. It isn't. The vast majority of people die extremely quickly. It's a terrible disease, and we need to do better for it. So that comes down to scientists. That's why I'm here. The quality of the research that we do equates to better treatments, and ultimately that leads to better outcomes. The charity, the foundation rather, very kindly are funding work in my lab to try and do something about this and give us a better therapy and give us better outcomes for this disease. So what's the idea? The idea is that if you look at a piece of pancreatic cancer at the cellular level, you'll see that actually it's not full of cancer cells, weirdly. It's full of another type of cells that are lurking in there. And our basic question was, well, what are they doing there? They're called fibroblasts. What are they doing there? Is that good news that they're there? Is that bad news? How are these fibroblasts hanging around in the cancer? And why is that important? To be fair, the answer might have been, it isn't important, but I'm pleased to say we have very recent data that show that isn't the case. So based on some work we've done before in breast cancer, we think that the fibroblasts protect the cancer cells from chemotherapy. So they stop your chemotherapy from working properly. Therefore, the presence of fibroblasts is obviously bad news. Pancreatic cancers are rammed full of fibroblasts. That's based on breast cancer. We don't know that that is the case in pancreatic cancer. So the Three Bears Fellow that the foundation have been funding has spent his first year trying to prove, is this the case in pancreatic cancer as well? Now that's a fiddly business, and you need to grow these types of cells in a dish in the lab, throw chemotherapy at them, grow them on their own or with fibroblasts or with lots of fibroblasts, with not so many fibroblasts, and try and assess whether the chemotherapy is working properly or not. And actually to do that experiment, there's an added layer of confusion because you've got to find yourself some pancreatic fibroblasts. So the first thing we've done in the last year is we have recruited pancreatic cancer patients in Leeds. We've accessed pieces of their tumour and we've grown fibroblasts out of those pieces of tumour. So we're now using in our experiment fibroblasts that have literally come out of someone's pancreatic cancer. It's exactly the right type of fibroblasts we're doing this experiment with. So we've got a good model system. That's the first thing we've achieved. They're fiddly to grow, actually. It's been surprisingly difficult, but we've got there. And next, we've been mixing up these cell types, throwing chemotherapy at them, and trying to establish whether the fibroblasts do what we think they will do. And I'm pleased to say about 6 weeks ago, we got our first, this actually is right. The idea is correct. Fibroblasts definitely are protecting the cancer cells from chemotherapy in pancreatic cancer. We knew it was the case in breast cancer. So what are the next steps? Having proved that our basic idea is right, and I can assure you Lewis was pretty relieved about that. He was getting a bit twitchy about whether this is actually Tom's a fool and his idea is wrong. It's correct. Having discovered that, the next step is to try and work out how to stop it, to stop that conversation between the fibroblasts and the cancer cells in order to take away the effect of the fibroblasts. Chemotherapy should work properly. So hopefully what I will get the chance to do is come back next year and tell you that hopefully we've reached stage 2 and discovered how to try and stop that conversation between those cell types. Thank you.